Hi, I'm Nick, and I'm here to present a solution to Carl's vacation. So, in this problem, we have Carl the ant, who is vacationing in Egypt, and Carl is on top of one of these pyramids. And he doesn't want to be on top of this pyramid, he actually wants to be on top of another pyramid. So, what he will do is he will crawl down the pyramid he's currently on, and then walk across the desert a little bit, and then walk up to the top of the pyramid he wants to be on. Now, Carl is in the desert because he's in Egypt, and he doesn't want to spend forever walking. So he wants to know the length of the shortest path to get from where he is to where he wants to be. So how do we do this? It turns out that there are two different approaches to this problem. So the first one is based on the idea of ternary search. So let's consider fixing the point at which Carl starts walking up the destination pyramid. So if we fix that point, and we say that Carl was always going to walk up their pyramid in this way, and then we consider that Carl was on top of this pyramid here somewhere, we can ternary search around the perimeter to see at which point would be minimizing the distance that Carl needs to walk to get to the destination. Now, we don't actually know what the optimal point is on the destination pyramid either. So we would also have to run a sort of nested ternary search on the destination pyramid. And this ends up being fast enough to work within the given bounds. Now, some people don't like ternary search, so there is sort of a solution that doesn't require using this structure. So what we can do is, instead of thinking about this problem in 3 dimensions, we can try to just think about it in 2 dimensions. So each of these pyramids has some height, and so depending on which direction Carl is walking, instead of thinking of him as walking from like above the surface of the desert, we can pretend to unfold the pyramid. And when we unfold the pyramid, there are these 4 different locations that Carl could be at corresponding to the face that he decides to walk down. And so you can unfold both of these pyramids, and then there are only so many combinations of paths that Carl could reasonably try. So this is a shorter solution to write in theory. You don't have to deal with nested ternary search or floating point or anything such as that. However, there are some tricky edge cases that you have to be careful about. So imagine, for example, that you have 2 pyramids that are really close to each other, but these pyramids are extremely tall. When you unfold them, the unfolded locations might end up being in the wrong place. So we'll say that the starting location is the left pyramid and the ending location is the right pyramid. So one of the unfolded locations here is actually illegal to consider because it corresponds to sort of walking along a face, but if you actually map that to the path that Carl would actually take in real life, it doesn't actually work. So if you do use this solution, you have to take care to exclude paths that don't actually map to a real path that Carl could actually take.